let's continue the second exercise in this mastering OpenSCAD within 10 project. We will follow Jacob's guide to make this wall anchor, these parts. So it's two type of the one is the rectangle, one is rounded. So in the right is over the website. From here book you can go to here. So let's first to make our new file and close our earlier one, and let's save. It's here, 02 wall anchor. First, so we have this basic model. So wall anchor with a square and round shape. So we may have these two shape, and you can see here it's cut by this different time, this shape, and also cut by a line. But there must be able to make that in certain looping. So we will create this one. And from this practice, we will try using the 2D basic shape square and circle and make them to extrude to 3D. So linear extrude. So let's starting to do that. First is give some basic explanation. Special wall anchor with lots of adjustment. All sides in millimeter. It's a good hobby if you can put these units here. So first we define our module, wall anchor, and with this one, and then we call wall anchor. So that's nothing happened because we don't have anything here. We will have our the perimeter. So let's use this way. So drill hole diameter. So remember I mentioned in the earlier practice, I prefer to put the default value in your the module definition part, so that you can call that in the just a simpler way. So it's cool. Diameter equal to 5, and another is we will give a length equal to 50. So we have all those, and then we have our working model. And this we will give our comments is a drill hole diameter. This is screw diameter. Last one is the anchor length. So it's still also nothing happened, but this is our base. So let's save that, and also we are starting to do the second one. So since we are going to add quite a few perimeter to our module, we arrange perimeter as vertical. So that is also easier way for you to read the code, because that can help us to add some comments. We will add the round version of the anchor as an option later. So first we did this square one, and I believe in the later part is we can make this the condition so that we can choose round or square. So then let's starting the real coding. So side length equal to the calculation square power drill hole dn 2 times 2, then make this half, and we have this one. So first we have this side length, then we will have this square side length, center true. So first let's see what was this one. So then this side length power. Yeah, so first here I forgot one, the close parentheses. So we have this one. So you can see here, we got this side length is this drill hole. Drill hole is this for your school. Your school is putting this one. So we have this 8. So we put that in the center. These are the 2D, the square. So that is 1, 2, 3, 4. So 4, and move it to center. So if we don't have this, so let's make that. So you can see here. So that is the side divided by 2. So because we have this diameter, so we are putting that into this square. So let's have this put in the middle. And what we will do is we will make the linear extruding. So linear. You can watch my tutorials videos to understand more detail about this 2D to 3D transformation. So one is the linear extrude, another is rotate extrude. So this one we use the lens. And better you make this into a tab. Now we have this one, so we extrude this. So before we made any further things, is now we have our base material. It's the square. So if you change this to circle, you will get this circle, the square, but circle need certain different parameter. So let's starting with this square. So we have this one. So that's the second part. Let's change further things. Moving on, we know that a power with 2 plus b power of 2 equal to c power of 2. That's the for this formula of the right triangle. So now is if you want to get this a, because a and b are same, the length, then you can have this c, the power of 2, then divided by 2, then that will be our a powers 2, then that will be squared. Then that is the formula for this one. So if you want to see the mathematical background, this is the one. And then let's moving on. Is we are going to make some more the parameters here. So one is a drill hole. We already have 8 screw DM length, and now is we will adding the oversight. Oversize equal to, don't remember here, you need to add this comma. This oversize is outer diameter oversize. And also we will have our outer taper. This equal to 0.75. This we should not have this comma, I suppose. So let's follow this, and then outer taper factor. It's fine. So it's not create error. So it looks like it's you can have this. It's nothing to have a difference. But my suggestion is you should not have this the comma in the end. So that's not good. But looks like it's sometime is in the book is no. Some for this one starting from this has this one. But let's keep this consistent. Then we have the create another calculator, alter dn equal to drill hole dn plus oversize. So when you keep calculating, you just try to considering is what's that looks like, because there's no the model, so change. So let's just leave that and move to the number 4. So for the transformation over a perimeter scale, so if you come to here, we can have this scale make that not in this even the same size. So let's keep adding more the perimeter. So first is outer type. We will have an inner taper. 0.2 inner taper factor, and the last one is inner taper end equal to 0.3 without this comma. Relative angle of the inner taper along length. So it's quite clear on this description. Then what we will do is we define the the hole, and this hole should be the one divided from removed from the original square. So we have this, and now we have this hole should be removed. So let's put this one. So we have the difference. And we should create like this. So this one is the difference. This is the first part. And then we will remove the hole. Then we should create the calculation. So ABS taper end is equal to length times inner taper ends. So let's make this into one tab. Taper dn equal to screw dn times inner taper. So that is a factor. So with that is we can now make something. So it's better is we do this unit because then let's first make some drawing. So let's have a look. Is cylinder. What's that looks like? Cylinder D1 is screw dn, D2 taper dn. H is equal to ABS tape end taper end plus 0.01. So that's just ensure is a little bigger than the base one, so that you can remove that. So that is 1. 0.1 should have this finished. So let's see what's the error. Ignore is the inner taper, inner taper. Here, typo. And we don't see that because we don't have the transparent. You can see if I make this vice versa as bigger, so you can see that. Or let's make this square transparent. Let's have a look. If I make the F5, see here, it's actually make this hole inside. So that is the one, and we need another. So let's copy this. So that is the school, is the table, DM, taper, DM, D2 is the cylinder, and we don't have that D2, so just H. H is the ABI length, minus ABS taper end, but here is 002. So I can put this here first, and we need to translate that. Translate, X is no need, Y no need, just the ABS taper end. You don't see any the part. If you read that, you can see here we have this one. So now if we don't have this, you can see comments that you don't have this the ending hole. So now let's we have this tool. Let's make this rendered, and we now we will union this. Union them and make that inside. That's no difference. We use F5 and we put face number more smooth. It's kind of the smooth, but we don't need is 100. And this we have that getting the shrimp. So we have this scale. So that is the translate, and also we will keep translate this unit. So translate. Zero minus 0.0001. So that is the thing for now. Let's moving on. We should have a small side of this one. Preview individual geometry part by temporarily prefixing them with this highlight. So let me see here. See, I highlight this to be removed one. So then that's you can see like this. X, I put X here. It's like let me see. It looks like here is kind of bigger. Let me check the perimeter. 02, 03, 07, 2, and screw. Let's see, the screw is 8550. That's correct. And then here is D1 is screw DM, D2 taper plus 001, ABS taper end, taper DM, length minus ABS taper end plus 002. Here is 24. Here is minus 0.01. A taper is this times the inner taper, correct? Length times the inner taper end, ABS taper ends, and this one is no change here. So inner extruding. So we linear, so we should have a scale now. Scale is the outer taper. So let's see. Scale outer taper is 0.075, and here is power is not drill, it's the outer DM. 2 drill hole DM plus oversize, and the side length outer DM linear. So I have double checked all these are correct now. So we are continue using that. So you can remove this highlight, then you have this one. So with those hole already built. So that's good. Is we are now putting here. So let's save to another one to continue. Since our funnel shape is the subtractive part of the different operation, is somewhat difficult to model the shape blindly. If we prefix the funnel shape with an exclamator, that's just explained, and run preview, then only the funnel shape will be drawn and no other geometry. So that is the skill or the tactic for you to make some modeling in some inside. Our wall anchor is still missing the ability to expand when a screw is screwed in. So to allow such expansion, we slid the anchor on all 4 sides using cubes and Boolean different operation. So that is the one we will making this, and then you can see in the later on. So I will stop here for now. So and to continue with the next video on this rest of the part of this project 2. See you.